Great, so welcome back to grade 7 math. We're now continuing on chapter 7.5, which is on dilatations. And dilatations are really neat because they're the special kind of transformation that creates similar shapes. And if we saw before, similarity means that they have the same angle, so the same shape, but they're not necessarily the same size. And so what we're going to be looking at now are dilatations, which means we're either shrinking or we are expanding shapes. Now, in this case, when we're looking at a dilatation factor, and I say what we want to do is increase the size of this triangle by 2, it is not 2 times the area. So what we're not looking at right now is dilatation is not talking about the area, but instead dilatation factor talks about the side length. So how long are the sides going to be in comparison to the original one? So if I look at this first example here, it says dilatation factor of 2. This means that the image will have side lengths twice as long, or 2 times the object side lengths. Remember, the object is the original one. So in this case, dilatation factor of 2 means that the side lengths will be twice as long as the original one. So here are the steps in doing this. I'll change my color and I'll choose a thinner line for this case. And let's just choose green. So I'm going to connect A to all 3 of the vertices in my triangle. Great. So that's what I have here. Now what I'll do is I'll take my ruler and I'll measure each of these side lengths. So let's just start with the long one since it's already prepared for that one. And I have that's 7.5 on my page. On your page, it'll be completely different. So on my page, I have 7.5 centimeters. That means the image will be at twice that because the dilatation factor is 2. My new point will be at 15. So if I write it this way, let's just move this away for a second. If I give this a name and I'll call it M, so that means the distance from A to M is equal to, or sorry, that's the original one. So 2 times A to M gives me the original, my new image of A to M prime. So twice of that gives me all the way to M prime, which is all the way out there. So now I'm going to continue on with the rest of them and measure those. So let's move this over and see if we can move this out of the way for a second. And let's measure this length. So that's 2.5 centimeters. So that means the new one will be at 5 centimeters. Let's just choose green. And we'll label this point L and this one K down here. So that means 2 times A to L will give me A to L prime. And similarly, 2 times A to K will give me A to K prime. So this is the dilatation factor, this 2. So now if I move my ruler again, and I find the distance from A to K, says 2.8, so twice that is 5.6. So let me find 5.6, about there. And now I have my 3 points. So now I have L prime, which is up here. I have K prime. Let's just move this ruler out of the way since I don't need it yet. K prime is here and M prime was still over there. I'll now connect all 3 points and I'll choose a different color this time again. So let's choose, well, let's stick with green, a darker green now. And let's connect these dots. Great, so that's close enough. So what I have here now is I have a triangle where the side lengths are twice as long as the original side lengths. So if I just write these in, so this was at 2.5 centimeters, and this one was 2.8 centimeters. So that means now the doubled distances, now I have side lengths that are twice as long as the original. So if I actually move this triangle, oh, I can't, but if I take each side length, I can see that this is twice as long as that one. The long side is twice as long as the original, and then the other one as well. Now, in terms of the area, remember, we could hypothesize that this 2 means it's also twice the area. But if you see here, more than 2 of these triangles will fit into this giant one. So let's even see it. Look, see, I have one here. I have another one here. I have another one here. And if I turn it around, I'll get a fourth one. So if anything, it's 4 times greater in terms of area for a triangle. So just to review what a dilatation is. So a dilatation is the increase or decrease of a shape using side lengths only. And the procedure is connecting the dilatation center to each point and then multiplying by the dilatation factor to get the new point. So I'll put the video on pause so that we can try the next example. You'll notice that the dilatation factor is less than 1. So now the multiplication will be less than 1. So you could predict that this shape will be smaller than the original shape. So this is my original shape and I have the new one. So we can try that one out in class, and then we'll be looking at this one. So now let's work on number 6 together. And so let's see these two triangles. I'm telling you that they're similar. They're not to scale, but they are similar. So what we'll need to do is find any corresponding or partner sides. So let's take a look to see if we can match up any of these sides together. And we see that GH is actually partnered up with JK on this side. So first of all, let's just answer a couple of these questions. Why are the two shapes considered similar? Well, they're similar because they have the same angles, and they also have proportional side lengths. And then letter C, which side lengths are corresponding? So in this case, the angles will always be in the same kind of area. Now, the side lengths that are corresponding, we saw that GH is going to be proportional to, so that's a little bit of a funny symbol, which means it is in the same ratio as JK. Also, we have that FG will be proportional to the other side, which is JL. And lastly, you can try to figure this one out yourself, but FH is proportional to KL. Now, what is the dilatation factor for both of these triangles, and how can you tell? Well, what I'll need to do is I'll find out any points that I know. So I have first here, I know the 10, I know the 15, I know the 8, and I know the 21. But what I'll look at is the corresponding side lengths. So 10 and 15 are the two that I know that are corresponding. So what I can do is I can find the scale factor for both of these. So the scale factor for these, so to go from 10 to 15, let's just erase this little arrow over here. So to get from 10 to 15, I needed a scale factor of multiply by 1.5. And because it's proportional, that means what I do to one side, I have to do to all the other sides. So let's go back to my highlighter and let's put this one in green and this one in blue. And so the green line, its partner is over here. So again, I follow the same scale factor, so times 1.5. So if I do 8 times 1.5, I will get the new the new side length of 12. Now I have this 21 here. So what I'll need to do is, if I'm going backwards to the smaller one, I don't multiply by 1.5 anymore. Now I have to go the other way. So let's just go back to my arrows. And let's choose a blue arrow. That'll bring me back over to this side. And so now I take 21 and I divide by 1.5. And so when I work backwards, what I'm doing is I'm finding the smaller side length. And so if I find that on the calculator, or if I do this in my head, then I find that the answer is 14. Because what I'm doing is I'm dividing by 1.5 instead to go backwards. So the scale missing lengths for the similar shapes are 12 for side length JL and 14 for side length FH. So what is the dilatation factor? Well, I know the dilatation factor is 1.5. And how could I tell? Well, because I know that GH is proportional to JK, what I did was I found the ratio of JK divided by GH, and I found that the answer to be 1.5. So what I want you to do for homework, for the video homework, is I want you to complete this question, so question B. And so in class, we'll be checking out the answers, and I'll see whether or not you've actually built this trapezoid with a dilatation factor of 1/2. So review all what we did today with looking at similar shapes, looking at proportional sides, and looking at ratios to find the missing the missing side lengths, and also how to create dilatations or similar shapes using a dilatation. Great, so hopefully you understood this lesson.